Welcome all. Good morning, afternoon, or evening, depending on where you are. My name is Praful from Corrosion Radar and your host for CUI or Coffee, which is aimed at promoting online discussions within the asset integrity community to exchange experiences and ideas. And today is a very special session as a finale of this season. I've been joined by my colleagues, experts in their domains, Shiraz Nasser from Corrosion Radar, CEO of Corrosion Radar, James Rosenshine, Head of Business Development, and Mehrdad Silatani, who leads operations of Corrosion Radar. A good day to you. I will pass the ball to Shiraz to quickly introduce yourself.
Thanks, Praful. So this is Shiraz Nasser. I'm the CEO of Corrosion Radar. I have more than 15 years experience in asset integrity and more specifically in NDT and structural health monitoring. I have been involved over the last years in developing and deploying new NDT solutions. And in the last couple of years, I decided to focus on CUI and bring to the market new solutions through Corrosion Radar.
Thank you, Shiraz. James, would you like to say a few words about yourselves?
Thank you, Praful, and it's great to be part of this. I joined Corrosion Radar at the start of the year. My background, I've been over 15 years working with emerging disruptive technologies, going to market, and the last 10 years in oil and gas, and last 5 years focused on digital transformation. So it's really great to be here at Corrosion Radar.
Thank you, James. Mehrdad, over to you.
Yeah. Hi, Praful. Hi to everyone. So my name is Mehrdad Silatani. I am handling the operations of a Corrosion Radar by training mechanical engineer. Spend a good 5 years in instrumentations, developing technologies for instrumentation companies, and now with the team commercializing a great technology.
Thanks, Mehrdad. So welcome all, and it's a special session for me personally to have my colleagues on the call. This community, which we started a few months back, CUI or Coffee, is rapidly expanding. Today, overall, so far we have more than 1,000 attendees cumulatively over the last few sessions from more than 60 companies, more than 30 countries. So it's been a great community, and we have had some great ideas shared over this platform. Today's topic is a culmination of a summary of the last few sessions, which the theme keep coming back. So today's topic is a case for predictive corrosion monitoring. It's an important topic, and I will share some of the results from the past discussions as to why this topic is so important. And this is close to Corrosion Radar, and that's why we decided to actually talk about it as to, is there a real use case of CUI and predictive corrosion monitoring for CUI? So this is how we will spend in the next 1 hour. We will aim to spend no longer than about 40 minutes for the panel discussions and presentations. We'll have slides from my colleagues, panelists, including a few polls, and giving enough time for about 20 minutes for the audience question and answers. So you can post your question by clicking on the tab and post the questions. We will, at any time of this session, we will see it and answer it at the end during question answer session. We may extend by a few minutes if there are so many question and answers questions. We may extend a few minutes, so feel free to hang around up even after 1 hour of the session. Our intention is to go deeper with slides, and this session will be recorded, made available to all the registrants. We may also give some mic to some audience members if they are willing. So if you are willing to do that, click on raise your hands. So let us start. Has everyone got a coffee, hot drink, masala tea, kava, mate? So let's celebrate and share the thoughts around CUI during this. So corrosion and insulation is a major topic. It's been clear from several decades that we are still talking about it. There have been several developments. And let's look at what we learned from the past few weeks or months of CUI or coffee. So can we have the slides up and running, which talks about what did we learn? So in the predictive corrosion management. So if we go to key learnings, so yeah, so here we see these are some polls we have selected from the past CUI or coffee, and that gives a summary of what the community is thinking about. The first question, as you see, and I think most of our panel members from the past have agreed to the audience polls here. On the left-hand side, you see, how do you rate the effectiveness of the current approach in your industry for CUI management? Overwhelmingly, 74% and 25%, about more than 98% says somewhat effective to not very effective. Only 2% says very effective, which means there's a change needed. There's a better practice needed, as always. So there's a change needed. The second poll, which is selected from the past polls, I want to show is what is the main challenge in applying an effective CUI management strategy. 45% selected standardize the data storage analytics. That's the main challenge. 21% says education about CUI and its importance and skills in handling it. And 34% says automation, integration of systems, processes, and people. So automation of various kinds, pointing towards digitalization. The third poll, which is very key, is which of the following can improve the management of CUI in your industry? Prevention, which is the by default, coatings, insulations. 25% says we need to continue improving that. Detection using NDT or manual inspections. Surprisingly, 5% only says that, whereas the current practice is that right now, the insulation removal and NDT. So only 5% says that's very effective to improve. But overwhelmingly, 70% says prediction of CUI, adopting digital analytics and continuous monitoring is the key, biggest improvement. So this prompted us to think about and propose this topic for today, that let's talk about a case for predictive corrosion monitoring for CUI, because that's where Corrosion Radar is standing for, and that's where my colleagues have agreed to join today on the panel. So next slide talks about whenever new paradigm comes in, there's a innovation happens. So I thought this slide will talk about, are we into early majority or early adopters in the predictive corrosion management? Has predictive corrosion monitoring for CUI finally crossed chasm? Chasm is a gap between an innovation and early adopters and early majority. So have we crossed this chasm? So I would request my Shiraz to actually talk about adoption, how we are seeing the adoption of CUI monitoring and predictive CUI monitoring. So have we crossed the chasm? Are we about to cross, or are we in the early majority or early adopters? So that's what we will discuss today, a case for predictive corrosion monitoring for CUI. So with this, it prompts me to ask Shiraz a question. Shiraz, there has been so much of discussion around this topic of CUI and monitoring and predictive. And some people feel that it's at the early stage right now. Some people feel that it's it's been adopted. Where's the line? So I would like to ask you this question, and through some slides show to the audience, where are we on CUI monitoring and predictive? Have it been deployed? There have been cases studied, and how is the adoption going on? So Shiraz, over to you with this question.
I think we have I can't hear Shiraz. Shiraz, are you?
I think the mic is muted, Shiraz, so you may unmute it. And
yeah. Thanks, Praful. Yeah, I'm just gonna share my screen. I prepared a couple of slides to exactly answer your question. I hope you can see my slides. Adoption, especially for CUI, I think it's time for adoption. The industry has been suffering from CUI for a long time. We have been using the same process for over decades. And if it's I think now it's the right time to use a new approach. So to start, I would like to share with you a story. Probably some of the audience here will recognize themselves. Some of the panelists will recognize themselves in this story. It's a very simple story that happens probably every day all around the world, where you have Rob and Bob in a refinery or plant talking about COI. So this is how the discussion goes. So the boss asks his inspection manager, Rob, what is the biggest asset integrity issue? Bob, of course, answers, it is corrosion under insulation. Then Bob, again, very surprised, and this happens all the time. Oh, I mean, we have coatings with 20 years lifespan. We have a good insulation, reliable NDT, a good RBI practices, and we're still talking about CUI problems. And Rob said, yes, Bob, it is still CUI management, very difficult with limited budget and resources. So this just to capture the problem that we see every day in the industry dealing with CUI. And just to support that with some numbers, CUI is the first asset integrity issue in oil and gas and petrochemicals. And 60% of pipeline failure come from CUI. This is from public information, but also some of the panelists we had during the number of CUI over coffee also mentioned big numbers like this. And just to take, for example, offshore platforms, 10% of the overall budget of maintenance goes to CUI. So CUI is a big problem. I mean, corrosion in general is the biggest failure mechanism, and CUI particularly is a big problem, and it is time to do something about it and adopt a different approach. So why is it the right time? Because I think the inspection and the NDT and the monitoring technologies are ready to support this new adoption and new move. So just I'm going to take you through a little bit of history of inspection. And this is a corrosion radar slides and what we call inspection 1.0 to inspection 4.0. We just classified how inspection has evolved and moved over time. So inspection 1.0 is the time where we are using manual observations, leak detection. So it's very, very basic. Then it moved to inspection 2.0 when we had a little bit more development in the instrumentation tools that we can use and still heavy on visualization. Then moved to inspection 3.0, which is more based on statistics, RBI, risk-based inspection. And now it's the era of inspection 4.0, enabled with all the technologies to move to automation, more predictive and more analytics-based inspection. So that helped us to move from manual to automated, from detection to prediction, and from reaction to prevention. And it is the right time to adopt a new way of dealing with our maintenance, and more specifically with CUI maintenance. So, and that is exactly what we are doing at Corrosion Radar. We are supporting and enabling this move to asset digitalization and CUI management digitalization. And that is done through a system or a solution that has three parts, what we call detect, connect, and predict. Detect is based on the hardware. So it's a number of sensors that we offer that we have developed in-house. We have corrosion sensors, we have moisture sensor, because moisture is the biggest problem that leads to CUI, moisture that trapped in the insulation and leads to CUI. But also we are working on other types of sensors for coatings and other sensors to enable us to detect and prevent and predict how CUI can develop in different types of assets. Then connect, as I said, this is inspection 4.0, so we want to make the system wirelessly connected, so remote inspect, and predict is really how to use the data, all these valuable data that we get in order to move from reactive to predictive CUI management. So this is how in a typical type of assets a corrosion radar system may look like. It is modular. It can be installed on pipelines in a coiled configuration, helical configuration, or straight line, for example, in the 6 o'clock position where normally the water settles in. It can be designed in a mesh configuration if we are dealing with a big surface area. So it's very modular and flexible. It is designed to really give you 2 very valuable information: where and when CUI is happening. So you have a risk profiling of your assets, and you have a condition-based inspection rather than blindly going every cycle, strip the insulation and do the inspection. At that time, it may be too late, it may be too early. And in both cases, it's a lot of cost and risk involved. So just to show you some examples of adoption, we have been installing the system on different types of assets in different geographies for different industries. I selected two examples here. One is on a column, production column. These assets are very important for the productions and also very difficult to assess due to the height. So here, a very typical case where this is a brown field. So the system can be installed for brown and green field. This is brown field. The column suffered a lot from CUI in the past. And doing a turnaround, client decided to adopt a new way of doing things, saving costs and also increasing safety. So corrosion radar system has been installed on selected location. You could see here on the top and the bottom. And the system has been giving us real-time data since to ensure that the column is free of CUI and that we can predict and prevent CUI. My second example, if I can move the slide. My second case is on again, this is a brown field. This is a complex pipe network where a section of it has suffered a lot from CUI. The client decided to install both corrosion and moisture sensor. And I will show you in this slide the results of some of them, the results from both sensors. So after 9 months of the insulation, the assumption here, of course, you have the best coating and the best insulation. But after 9 months, we have seen that if I take the moisture sensor results, if you could see in where I'm pointing here, that on that pipeline, we have detected presence of water pretty much everywhere in the pipe. So on the top, and in the low points where the water settled in. And if we also analyze the corrosion data, we have seen that at the top of the pipe, we have started seeing a level of CUI, and also at other points, lower points in the bend here, we start seeing a level of CUI. So the key learning here, when the pipe has been coated and a new insulation has been put, the assumption from the client that we will only inspect this pipe after 5 years. What we are showing them with real data that within the first year, you have pretty much water everywhere and you have a CUI process started. So maybe if you wait for the next 5 years, maybe there is no pipe left. And what we are trying to do here is give data for more informed, data-driven decision. So the decision could be prevent this altogether and reseal and look closely in the insulation, or shorten the inspection cycle from 5 years to 2 years or 3 years. So this is to prevent and to predict also how things can evolve for the client to take to take decision based on real data and prevent a lot of cost for repair and safety problems and schedule shutdown if CUI really lead to that point. So these are my slides for to answer your question, Praful. I hope that covered all the question that you asked me.
Yes, thank you, Shiraz, for sharing that, how CUI monitoring have been getting adopted in various assets. My takeaway from this is, yes, this is happening, and I will question about where are we in the chasm of CUI monitoring adoption, and that will be a question to you. And when you talk to various end users, oil operators, what are the main assets they see the usefulness of this? and what is the plan in their mind? How a typical process adoption starts.
Yeah.
Shiraz?
I think that there is a big awareness that CUI is a problem. The question is, there is an appetite to change it or not. That will categorize the company in two categories. Some companies are really proactive about it and they really want, because CUI, the problem is a long-term problem. Some, they see the short term of it. Okay, it's not my problem. It may happen in 5 years. It may happen in 10 years. I'm not going to be proactive about it. But we see more and more companies really willing to change this because they realize a lot of aging assets, a lot of assets suffering from this problem now as we speak. And there is a more appetite to take a different approach. Aligned to that is all the development that has been done in digitalization world, better sensors, better way of transmitting data wirelessly, better way of signal analysis techniques that has been developed. So all those enabling technology make also the adoption cheaper, hopefully, than comparing to what it was 10 years ago. And we see more and more appetite to do that. We would like to see more companies also having the same approach, but I think there are, what we see is early adopters and followers. But the early adopters, we see more and more companies getting into that, especially actually after what happened with also the lockdown. People realized that access to assets sometimes is not possible. Safety of people also on the side. So digitalization and remote inspection is becoming much more appealing and faster adopted, hopefully.
Thanks, Shiraz. I think that's a great overview of how predictive corrosion management is coming to CUI, and real cases are being generated and benefits are being experienced. This brings me to the point about market and the market trends and digital transformation as a driver of this. And I'll ask James this point and question about. James, you have also been traveling a lot, of course, in the past, and talking to a lot of customers and oil companies and petrochemicals, and seeing the market trend. What are your overall observations about? Shiraz talked about the adoption, but the vision of the companies and the market trends, the desires on the digital side and the corrosion management side. James, do you have what insights you would like to share?
Thank you. So it's been a busy 6 months, and as you mentioned, Praful, the first 3 months at Corrosion Radar, I was traveling a lot, spending time on site, speaking to customers and potential customers and partners. And then we've now gone online and bringing the community together using with CUI over coffee. It'd be fair to say nothing focuses the mind then, unfortunately, the pandemic that we've gone through, and the oil price crashing down and now slightly going back up again. It's certainly focused on mine. I mean, I've been in digital and working with digital on digital projects for many years. And to be honest, there's still a lot of talk, there's still a lot of hype. A lot of companies are trying things, but I think maybe trying too many pilot type projects. And I was working with an operator last year and they cut digital projects 430 down to around 80 because they were just trying too much. So what I'm seeing, certainly with corrosion under insulation, it's a fantastic and compelling use case for digitalization, but it's also focusing the mind now on for operators. And there was a recent article, Lloyd's Register, actually yesterday. I read an article through one of the news feeds, and Lloyd's Register they carried out a survey with FPSO operators, and they worked out that around about 40% of maintenance costs are unnecessary, and this equated to around £600,000 saving or cost that could be saved per year, and over an asset lifetime of around 15 million. And they're emphasising in these tough times, it's important for operators to obviously focus on on costs, and prioritize maintenance activities. So what we are seeing is that companies are now really thinking about change and the way they can do things, and predictive corrosion monitoring gives them that opportunity of being smarter and more optimized. Let me tell you a little story. I mean, I've got various experiences over the last 6 months, but I can remember one sitting down for lunch with a senior static engineer. Great conversation. I can remember the lunch well because I had this really dry, crusty roll and a very bland tea and ham soup, which kind of summed up the conversation away, because I was talking about his motivations, and to be honest, he was quite happy to not change. Maybe it was the stage of his career, but certainly, he was quite happy to, and he put it himself, I'm quite happy to sit behind policies and guidelines. If I do that, then I'm doing my job. Yes, we have incidents of COI, which has caused a problem. It's not really my remit. I'm just there to follow the guidelines and carry out maintenance work. And you mentioned about the outlook for the company and the particular plant was quite short term. So you can understand why, and in some cases, maybe there's not a business case. Whereas I've seen another extreme whereby we're working with an operator who have said, right, we need to do this. We need to get on with it. We need to adapt. We need to start looking at and looking at a showcase plant where they're going full digital and unmanned, and they recognise the benefits, and it's a bold attitude to say we just got to get on and do this. It's going to happen. So I've seen two extremes, and of course there's a middle ground, and a lot of companies are in the middle ground. And I spoke to a company, and the operations manager, he was actually the plant owner for this particular plant, and he bought into predictive corrosion monitoring. He recognises where it's going. He could see the medium-term business case, but he was actually worried about there and now. And he even admitted, I'm in firefighting mode. I need to just find out where there's issues and give me a solution that can just go straight to where the issues are, which his innovation team recognises is a vicious circle, because you're going back around, you're getting the same problem.
So obviously it depends on, James, it depends from your conversation over lunch. Lunch is a luxury these days with the colleagues. I wish we could have lunch not remotely, but physically. But interestingly, your experience is saying that there's a lot of variety of cases, right? On the business case, it may depend on the geography, it may depend on the type of asset, type of company culture. Do you have examples of how this is done in the sense of evaluated the business case and return on investment?
Yes, but let me just find out my screen. For some reason, my screen's frozen. I can't change. Oh, here we go. There you go. Excellent. So let's just talk about the opportunity. And we've spoken about this, and we had some really great guests over the course of the 7 CUI over coffee sessions. And one thing that really stood out about the business case, and also what's at the front of mind for most operators, and that's safety and risk. Rebecca from the OGTC, the first session, mentioned a couple of high-profile cases in the North Sea. An operator which, due to CUI, there was a significant incident which warranted a penalty of 1.15 million. But the actual compounded costs with actually dealing with that problem was over 10 million. Another operator who had to shut down for 28 days a normal export line, cost them 260 million. So there is a lot of high-profile cases that we know about. I'm sure we don't know about. I know the Energy Institute, Billy McKay from Total mentioned that the Energy Institute are looking into these cases and sharing these cases, so that it gives us all an opportunity to raise the profile in dealing with safety and risk, and looking at ways to improve that. looking at the labour intensive ways of going about inspection at the moment, and I think we ran a survey, and I think a good majority of companies are still, focusing on periodic inspection with a bit of risk-based approach. It is labour intensive, and Henrik from Shell and also Gino from Borealis, they all said that the most effective inspection technique, 100% accuracy, is visual inspection, but you have to rip the insulation, you have to carry out all the dismantling work and put the insulation back. It's costly. So how do we optimize that and moving to a data-driven approach whereby we can detect where and when there is moisture and corrosion will dramatically reduce the over-inspection that we see. Essentia talk a lot about over-inspection, over-maintenance. And that's certainly what we are focusing our cost-benefit analysis on in business cases, in addition to the safety and risk angle. And if we move on to targeting the actual business cases. So we've talked to many operators and different plants and different people within the plants, and what we've got to do is we can't just put sensors everywhere. It's not a big bang approach. We have to be highly targeted and prioritized. And I think Fran from Plant Integrity Management in one of the CI coffee sessions said we need to look at the fabrication and maintenance strategies to define, and the risk-based inspection tools to define where we start putting and rolling out the sensors. And when we're talking about brownfields, we are retrofitting the installation. So we need to, we need to work around those schedules, but it needs to be highly prioritized. So what we are seeing, and Shiraz mentioned a couple of customer cases, we're seeing companies focusing on the high value assets and critical assets like production columns, where it's difficult or costly to inspect or need regular inspection. Of course, conditions is a big factor too. And we're seeing, we're talking to plant owners and people in those plants who recognize that due to various different conditions, it's really driving the unpredictability associated with CUI. So we need to think about where we target the business case analysis and where we target deployment of sensors. We talk about green and brownfield sites. So again, when we look at greenfield, we ran a CUI over coffee session with Billy McKay from Total and Bruce McKenzie from Oceaneering, and it was focused on CUI management from cradle to grave. What was very clear from the audience participation and the panelists, that when it comes to new builds and greenfield sites, there's a great opportunity to look at a business case for sensors at the detailed design stage. So it's not for all. We have to be selective and get the timing right. But this is something that we are working with our customers and prospective customers on at the moment. We go through a cost-benefit analysis, something which we recognise that we need to help companies on. And through consultation, we take various inputs from those companies. And one obvious tangible hard saving that we can focus on is how do we optimize inspection and maintenance? How do we reduce partial stripping every 4-8 years, which is 15 or 20% or even more in some parts of the assets, down to say 2%, and what is the cost savings associated with working and using corrosion radars sensors? That's been quite successful. It takes a bit of time and effort, but certainly we can demonstrate tangible and hard savings. But of course, there are other benefits associated with the ability to precisely detect where and when there's corrosion in the insulation. That early detection can certainly help reduce and eliminate loss of containment, production containment associated with CUI. Again, lots of the operators have been open about this, and they've looked at their historical data and identified the average loss of production associated with CUI. And we've been using that information to start really building out the business case. And that's the type of information that really gets the attention of the executives, because when there is a disaster, with a zero unplanned shutdown, and sometimes it's catastrophic, that gets their attention, and we can put numbers associated to that. There are obviously lots of other benefits in terms of increasing the asset life, so in making sure that we can optimize the assets and their performance, increasing the intervals of inspection, rather than do a full strip in every 12 years, maybe you can extend that to 15 years beyond, or just keep it at precise inspection. So there's lots of benefits associated with and in the way that we can look at the business case. This is just an example. So I think perhaps we can see this example, you know, quite well. Some work we did, and you know, this is just a summary, and obviously we have to anonymize the data, but we looked at 4 assets, and over time, over a 12-year cycle, at a 4, 8, and 12-year period, the total savings, you know, just based on optimizing inspection alone, was substantial.
So James, thanks. So thanks for this use cases, and what I take away from this is what you're saying is normally you get engaged with the end user about cost benefit analysis, and it is done from the inspection cost savings by reducing the inspection location, you know, rather than doing blind inspection of a whole lot of locations, very targeted inspections, be it visual, be it NDT, but NDT will be required for verification, right? And the second one I take away from this is what the numbers you have shown is just from the inspection cost savings, but there's another level of quantification about loss of containment saving, unplanned shutdown, which is pretty much a discussion with the end user. So there's much more to that, and pretty much the saving from inspection is about 40 to 60% for a typical asset over a life cycle. So so from this, what is the typical process, James? You know, my question would be, how will the customer know whether they should do the cost benefit analysis, and how do you help them? You know, what are the inputs you need
it's a good
from them?
It's a good question. Yeah, it's a good question, because you need to find that emotional driver within the company. So by creating awareness across the inspection and maintenance community within an asset integrity community within a company, you will get 1 or 2 people that really get it, but secondly have the emotional driver to say, I want to do something, I want to change. You work with those people who want to, I suppose, be the poster child within the company to demonstrate value with us and prove value. And they typically have a genuine, a business case that's saying, I've got something which is we need to maintain and overhaul. Do we repaint? What type of painting do we use? We're only looking at a 12-year lifetime, so do we really need all the preventative tools that we need to put in place? Why can't we put sensors in now and then reduce the operational expenditure associated with inspection? So it's finding the emotional drive within the business. It's finding people that are willing to participate and consult with us on the business case, and we can walk through it. And that's been quite successful in doing that.
Yeah,
we
so
also see a lot of opportunity, Praful, with working with the service providers and the partners, and that's been quite useful in working with the companies that actually do the inspection and maintenance, who actually see value and want to demonstrate value to their customers in working smarter, and that's been also really good to see.
I would take this as what you're saying is it's not only about the business case for the end users cost savings. It's not only business case for the service providers, because this is an additional service they can provide. It's also an emotional case where people would like peace of mind. Effectively, they would like to sleep better, you know, knowing that the assets, the data is coming in, and then they know about their assets much better. Unpredictability of CUI probably is reduced in that. So, and you help that in the process. So thanks for that, James, and thanks for the great insights. And I'm aware of the time. I will request audience to keep putting in questions. There are so many questions coming in. We may extend the session by a few minutes to tackle the questions, but I will go to the next stage of this discussion, where Shiraz talked about that there's a lot of adoption of CUI monitoring. James talked about this big use case. CUI is probably among the highest beneficial use cases of digital transformation and digitalization, sensors and monitoring, and that have been identified by the audience in the past as well, and James is confirming that. But how do you deploy this, say, this monitoring system? So I'll ask this question to Mehrdad, because he gets involved and in discussion with the end users about planning the layout, installation, and the logistics of it. Mehrdad, so
Yeah.
what is your view on this, and do you have anything to share?
Yeah, absolutely. I have prepared a couple of slides. The short answer is very easy. If you pass the business case calculation and adaptation, deployment should be list of your worries. We make sure that this is a smooth process without any extra headache. And I understand often there's a lots of questions around more, I say, engineering questions. What is a sensor? How do you deploy it? How do you put it? What are the extra burden to my staff? So in order to cover all of that within the limited time we have, I prepared Praful a kind of like a story that I take our clients through a journey, that what would be the steps since the moment they decide to deploy the systems to the point that they start benefiting from what corrosion radar systems are reading and assisting. So I am trying to go to the next slide, and it seems today, oops, yeah, can you guys see?
Yeah.
Okay, perfect. So as I was mentioning, so I break down the overall process of a deployment to 5 steps. So there's an initial point where the client identifies the assets. All those previous steps of business case and everything is done. So now the decision is to go ahead. What we need to understand from a client is more information about that type of asset. I jump into that a little bit. And then what are the steps we take in the design and engineering? So we work with the engineers of our clients that to optimize where the sensors have to be deployed, and what is the least, let's say, complex journey towards that deployment. The third step is, once we have all of the design engineering done, we focus on the manufacturing based on that design drawings that are approved by the client, and we provide all sorts of manuals, step-by-step guidelines. I'm glad to tell our audience that we have, as a response to this new limitations of the new era that we are living in, that with the travel, so we are adopting a remote installation procedures that we provide a very thorough walkthrough, webinars, guidelines, and even virtual installations to be virtually present on the site while helping the people to install it. Once that is done, then it came to the step of the actual deployment. To give you an example, one vessel, 25 meters that Shiraz showed, it takes, I say, 2 locations, top and bottom, it takes, let's say, 6 hours. Because most of the work would be done beforehand, and on the day is just following the steps and going ahead with it. The last step and the most important part is, once everything is done, how the data looks like, what information will be added to the client. So I would jump one by one to this step. So the first step is the client need. So the first thing after the decision is made, what we will share with the client is a simple questionnaire about the location, the asset type, the zone is located, what sorts of installation is used, all the way to the considerations around data communication, accessibility to that asset. All of that will be captured in some sort of a questionnaire that you can see in here. Once that is captured, then the corrosion radar team works on producing some sort of a design and simple schematic to explain to the client. So to understand the future slides or the future content I'm going to show, I would like to spend a couple of seconds on this slide and explain for those of you that are maybe first time you're hearing about the corrosion radar system components. So the corrosion radar system, you can think of it as 3 main components. You have electronics called CR node. You have the bridge cables that they do the transmission of the data to proximity of the sensors and get connected to the sensors. And then you have the sensors installed on the asset. So 3 main components: electronics, bridge cables, and sensors. So once we have an idea of a schematics on how design would look like, we move on to produce the very detailed drawings for the clients that this will be done with the consultation of the engineers to make sure every detail is captured, and we leave the minimum amount of work left to be done on the day. So once all of this is done, then we move to the steps of a manufacturing, that how we capture all of those data, all those requirements, and we move on to create our system. So then the biggest component obviously is the electronics, which we call them CR node. These are represented with pictures. They come in different options, different communication options, wireless HART, LoRa, cellular, or offline USB connectors for this particular example. Once that is done, then the next step would be helping the clients step by step to understand the process needed to get the system installed. So how we achieve that is we provide a document called POI, Plan of Installations, whereby we go step by step of what needs to be done, what considerations needs to be taken once you want to install the system, from the point that you start unpacking to the point that your technicians will be installing the sensors or the electronics on the asset. Alongside that document would be obviously the certifications of our Corrosion Radar products and other the mounting equipment that we use, that we will also provide the data sheets for the peace of mind of the clients. Once you have covered that aspects, you move into the deployment itself. So to help me explaining this section, there's a little video, a couple of seconds video that we usually provide to the clients that, for instance, in this case, you can see the installation of Corrosion Radar systems on a, say, dryer or a vessel. That foam glass removed, installation removed. Then you put the sensors that they come in a pre-packed, as you can see in the pictures, corrosion or moisture sensors in the form of a wire. So then you use very simple installation. You identify the layout you want to install it, and then you put this glass fiber tapes on the sensors, and you wrap it or you mesh the column depending on what configuration we have decided is the optimum for monitoring. Once that is done, then the installation goes back on, and the sensors will be guided through the installation to the outside with a sealed glands. We don't want to create another point of entry of water to the installations. We are very well aware of that. So we have mechanisms to avoid that with the type of glands and sealings we have. Then there's a junction box that connects the sensors to the bridge cables, here as you can see in the video. And the beauty of this is, the reason we have a bridge cable is we provide the flexibility of where sensors are with respect to where electronics can be. There are often cases that your column is 40 meters, 25 meters, but having electronics installed at that height, it can create some logistical challenges. So bridge cables provide that solution, that you can have electronics far away, but you can connect them with the bridge cable to the sensors. Here you can see again, electronics. So bridge cable connected to the electronics, very simple installation, bolts and nuts fixed to a structure. Then the power connected, the bridge cables are connected, the system is earthed, and after that you have a complete assembly. That was an example of a vessel. So if I want to move towards example of a pipe, it's not that any different. It's again simple installation. If you decide to go with a helical fashion sensors, you have sensors wrapped around. You can use cable ties. You can use this high temperature glass fiber tape. You can have it in a straight configuration, and once you install the sensor according to the specification client requires, the rest of the steps pretty much follows the same as the vessel, that you have the bridge cables and then you have the electronics connected to it. So that brings me to just showing one example in practice what it looks like to install the sensors on a production column. In here, what you can see is obviously, as our participants and friends know better than us, drawings from the point of a drawing to the point of installation, there are always surprises. And the beauty of a Corrosion Radar system is because it's flexible, we can face the surprises and we can go around them. Whether it's let's say it's a new inlet to the column that was not obvious in a 30 years old drawing, that's fine. The sensors are flexible enough to go around it. Whether there is a new piece of instrumentation installed, we didn't know, that's still okay. The sensors, again, because they're modular and flexible, they can cope with the situation that is present on the field. So that gathers all of those points that now we went to from the client needs to the design, to the manufacturing, to the deployment. Now the systems is deployed, but what it looks like after that. So very briefly, to just give an overview of what one of the options that clients have, which we advertise, which is the dashboard. They can have on-premise solutions or other sorts of report mechanisms to be given to them as well. But let's look at the dashboard. So clients, the systems will start communicating the data back to Corrosion Radar servers. The client will be given a username password, access to this Corrosion Radar dashboard. What would they see is a three-tier or 3 layers dashboard that you have. First layer, asset list, asset information. For example, client has let's say a site in Spain, a site in, let's say, South Asia or America. They choose the site, the number of assets in there. They choose the particular asset they're interested in. Then they get a brief description of what is that asset, how it's been installed, the last updated pictures of that. The third layer, which is the most important part, is obviously the analysis. So let's take a quick look at the example of what analysis looks like. So what you can see in here, the dashboard presents different ways to provide information. One of the ways is this heat map graph that you can see in here, which is essentially, you can think of it as a history of the measurements that compiled one next to another and creates a colorful figure that you can see. So figure on the left is the heat map of an example asset. You can see at the end of it, there are two small, I'm not sure if you can see my pointer. There are indications of something is happening. So you have start of the sensor as a 1 peak, end of the sensor as a 2nd peak, and then you start seeing a small indication something happening after a number of days. So on the right-hand side, you can see the comparison of any particular point in time to the first data collected from the sensor. So you do these comparisons in here. But what does that mean? That you done that, you saw a peak, but what does it mean? How can I, what is the information to me as an operator? So if you want to understand what is the information, is Corrosion Radar then provides what that location means in respect to where the sensor is installed on the asset. So for instance, the peak number 1 is, let's say, at the 20 meter location from the bridge cables. So then we can identify, you need to look at this point and do the target inspection on this point, or another point a couple of meters down the first inspection point. So yeah, that is pretty much the journey to the installation and deployment, Praful.
Thank you, Mehrdad, and that was quite detailed. I think the engineers in the audience will appreciate how this is installed, and I think that was a very revealing, insightful presentation. My quick question and actually point would be that the data which you showed is actually raw data, right?
Yes.
Very raw data, and then how much interpretation is required and how much processing is done after that?
Very good question. So that's correct. The data you can see there was a raw data representation with a small, I said, minimum level analysis done on it. But the beauty of Corrosion Radar systems would not be to look at that point in time. If clients would like a further analysis, as you highlighted or Shira shown in the previous slides about the prediction, then there would be what you can see that there as a slider that you look at the data at this point, you can continue sliding it forward in time and see how that trend may look like in 6 months, 1 year, 2 years down the line. So there are levels of analysis, Praful. The basic level was what I showed in the slides. It's still useful because it identified the location, but there are more and more analysis can be done on the data, which we offer to the clients, and based on what they need is decided and given to the client.
And what about the training and support to the end users? Say, can they interpret themselves, and can Corrosion Radar support in the process?
Yes, so we provide trainings, and we provide trainings for the clients to have the basic understanding of the data in terms of the location and when it's happening. But I believe the ultimate value, which is the prediction, and the title of this session is best done by Corrosion Radar engineers, because we have access to the vast amount of data and built up a knowledge base of many different factors. So the basic level can be done by client. We provide the training, we enable the client, and further analysis beyond that point, I think would be corrosion radar at this point in time.
Thank you, Mehrdad. And you know, that was a great panel discussion. I would say now we have to move to question and answers, because I can see already a lot of questions coming in, and we have limited time. So I would also suggest at this point that, because we have 5 minutes left in the, you know, we may extend by a few minutes this session. So audience is free to join, remain connected, and remain on the session. And we will try to address as many questions as possible. And in some questions are unanswered, we'll get them over email, right?
Yeah.
So let's go over the questions. There are so many interesting ones coming in. The first question coming in: when we say corrosion sensor, what does this mean? Is it an ultrasonic wall thickness of vessel wall, or is it other technology? And I think this goes to me, that the principle of corrosion sensor is electromagnetic guided radar. You know, to answer that, it's not ultrasonic wall thickness. It's an electromagnetic guided radar. Both our moisture sensors and corrosion sensors are using the same principle. It is based on microwave principles on the sensor. So anything happening on the sensor is detected. So be it corrosion, because the external layer of the sensor is sacrificial carbon steel, and when it faces CY corrosive conditions, it corrodes itself, and we detect the location using microwave radars. And similarly, moisture sensor, where it is embedded in the insulation, when water comes in and touches the sensor, it is detected using radar principle located. So it's not ultrasonic wall thickness, it's electromagnetic guided radar, but it's a complementary tool to NDT, because this tells where to do the NDT to reduce the scope of NDT. So that's the answer. The second question coming in is, probably this goes to James. Would like to know where the customers have already started digitalization within respective companies before adopting corrosion radar. So I think this goes a bit beyond corrosion radar. This goes to about digital transformation. So do we see adoption of corrosion radar in the companies who have already started digitalization journey, or we are the starting point? So James, what do you think?
It makes me smile, because it's very subjective. And we actually, the last COI over coffee session about a digital mindset, we touched on this. You know, how do you define digitalization and a company digitalizing? Because we go back 20, 30 years, and you know, we moved to Excel spreadsheets, and then we're moving those Excel spreadsheets to, you know, online data sharing with Google Docs. How do you define digitalization? But it'd be fair to say, yes. Well, the companies that we're working with, they naturally are all saying to their shareholders that they are digitalizing. They need to be seen to be digitalizing, and a lot of these companies have now got people on the board who, you know, have a chief digital officer remit. So yes, there is. It goes without saying, a lot of these companies already digitalizing and have a strong strategy around that, and core expertise in house, which is growing. So when it comes to sensor technologies, you know, we typically be working with the innovation teams who you know, really do understand the benefits of digital and are trying to promote use cases internally. When we are talking to the maintenance inspection people, then there is obviously some work involved with education and getting them to think differently. So, but yes, these companies are already thinking about it and are digitalizing.
Thanks, James. Next question is, actually there are two questions from two different people, but similar question. And I think this goes to Shiraz. Great presentation. How easy can I retrofit the sensors to existing pipelines? Do I need to remove completely the insulation to install the sensors? Is it an additional cost? Shiraz, what do you think to this?
I think this is between me and Mehrdad, to be honest. I mean, what we have been doing so far is use the window where either you have a turnaround or you have already scheduled maintenance for that piece of pipe or piece of equipment to remove the insulation. So it came to to the end of the cycle where to remove the insulation. And we use that window to install our sensors. And from that point onward, you change the way how you manage your COI based on the data that the sensor is giving to you. So the benefit that James and Mehrdad went through, what I would add to that is you can extend the next cycles, and you will focus only on the points of concern that the sensor will indicate to you. We can actually retrofit a certain length of the sensor if it's required. We cannot. The sensor comes at 100-meter length for the corrosion sensor. Probably we cannot achieve the whole length, but if required. But what we prefer is to really have a better view on the surface of the pipe or the equipment before we put the sensor, because that is our T0. That's our starting point, because we are monitoring. We always compare to the time, the first time where the sensor has been installed, and anything after that point is a comparison on how the degradation is moving forward from that point onwards. So yeah, Mehrdad, if you want to add anything.
Just Shiraz, you covered it all. It's just to complement what Shiraz said and going back to the previous slide. So if you think of corrosion radar, two questions: when and where. So our default position is clients wants to know both. But if you, for example, know a certain location, the question is not where. You're more concerned about when to inspect. Let's say around a particular flange, let's say around a particular location. Then the question of retrofit is very valid, and we can do that. So we can still provide a lot more value with regards to the question when, that you, for a small patch of the sensors, for a small area we cover, and then after that point, you stay on top of the journey of the water within installation, how long the water is there, does it dry up, where is it coming from, where does it travel? I think that's unique to corrosion radar in that sense, in the information. When do you need to act? Is it deteriorating faster than what you thought? No, is it slower? So I actually have more time. So two questions, where and when. If you want both, and where, which means the long range, we need to remove it. But if you're more concerned about the when and a particular location, then still we can retrofit a small length.
Okay, thank you, Mehrdad. And I think actually the next question actually goes to you again. Would corrosion radar support deployment in the USA? Mehrdad, how can remote installation be done in the USA in particular?
Very valid question, and I am glad to see this question of expansion to US is keep popping up through emails or website or even the webinar right now. Where we are at this point in time, we have not done a deployment in US. The reason for it was not lack of ability, was we were going through the compliance to make sure that everything is done and safe. So now I think we passed that hurdle, and it can be done. I am very more confident after the last 3-4 months that we invest a huge amount of time and resources in creating a virtual trainings, that this can be done even without the need of corrosion radar team to be traveling. So short answer, yes, it can be done, as long as they're happy to sit down with me or my engineers for a good couple of hours to go through the installation process.
So, Mehrdad, are there examples of remote other geographies already being covered?
Yes. So very good example, a very good question. So we, as you know, we are in Europe. So our predominantly focus has been on Europe, countries like Netherlands, Spain, and since, I guess, just before this new world that we're living in, lockdown started, we started expanding to Southeast Asia, countries like Thailand, and they have been successful so far, those efforts. But again, there's a lot of factors. So I'm aware that the communication, time difference, the language, and all of that. What I say is possible, and I am confident about it. That we in our company we speak 12 languages. So if among ourselves, so if I'm sure if someone wants to install it, we can find a way for it to install it at any location.
Thank you,
forgot Middle East as well.
I'm sorry. Yes, Middle East. I missed the Middle East.
And soon Latin America.
Yes.
Great. So actually, the next one is a comment more than a question. So it says, visionary technology, thanks for sharing. So it goes to all the panel members. smile on the face.
Yeah.
The other question which is coming is are there other use cases other than of corrosion radar technology other than moisture and corrosion sensor? So I will probably answer that yes, there have been collaborative work with various companies we are doing on. They express that coating is a barrier and coating does not necessarily damage for when water comes in. So moisture sensor, can it give the indication of coating damage? What we have been working on and trying to implement in various sites is the coating risk based on moisture sensor. So we know the history of the moisture sensor detects water, and that water, drying cycles, wetting cycles, and the temperature of the asset, that is detrimental to the coating. So the coatings normally can last 15-20 years, but in ideal scenarios. But when water comes in and it starts to wet and dry, it actually reduces the life of that coating to. So basically, I call it abuse of the coatings by water. So if we know that factor, the coating life can be estimated from low, medium, high. So the risk of coating can be low, medium, high, and we are trying to work with companies on estimating that, because this is another estimated parameter. We call it virtual sensor coating risk. Similarly, for stress corrosion cracking, chloride stress corrosion cracking of stainless steel structures, moisture sensor can be used to estimate the risk of to stainless steel structures. No water, no corrosion, no water, no SCC. Water is required. So if we detect water, we have a better understanding of the risk. So yes, so there are derived parameters which can be used. So that's where. The next question again goes to any of you. Say, I'll start with Shiraz. What is the biggest hurdle to more widely adoption of proactive monitoring on brownfield sites? That is move from single item management, a single pipe, to a site level management. What is the typical process? And how do you plan to climb those hurdles and remove those hurdles? Shiraz, what do you think?
I think for me, the biggest hurdle is the mindset. I mean, we had a whole panel on it last time. It's the mindset and the change from seeing short term to seeing the benefit of a long term adoption of a new process. So, and that move from inspection to really long-term monitoring. And that comes not only the technology, it comes how the ecosystem can work together. It's a digitalization ecosystem. So it will require a new way of working together between the client, between technology providers like us, between the service company, automation company. So that needs a different way of working. It's not a silo working anymore. And also, even so, from technology, from the collaboration ecosystem, and sales models. So we cannot charge with the NDT. You charge the person going on the day doing the inspection. With continuous monitoring, it's a different concept, different. So the sales models needs to also follow. We see a lot of appetite for OPEX sales models. So but basically data as a service, because that's what you are providing. So it's a whole mindset shift that needs to be ready to adopt this new, because it's not we are introducing a new technology. We are introducing, through digitalization, we are introducing a new way of doing things and a new way of interacting with the supply chain and the ecosystem. So for me, the biggest thing is the mindset.
So it's a mindset issue. And I would ask this question to James as well, because James, you bring tremendous amount of experience on digital transformation in oil and gas industry. And what are the biggest lessons and biggest hurdles as this question posed? How do we cross these hurdles, if at all? And what are the biggest lessons in digital transformation from your experience?
From my experience, I mean, I was involved with a major business transformation program, which started from a minimal viable product and was rolled out to various projects. And it'd be fair to say it's great to get executive sponsorship and get the right mindset at the start, but it needs to be, industrialized, because we know in oil and gas, people change jobs every 2 to 3 years. People are retiring. People are now having to go into different roles. and there's lots of change. So there needs to be a sustainable program built which can drive change in that regard. And it's very important to continuously learn from the projects. And I think, looking at the question also, what made me think is where we're seeing the opportunity to start looking at scaling the sensors based on an OPEX model is engaging with the key suppliers, which the companies that we're working with see as trusted advisors in managing those types of programs. So, you know, we're working with various partners, automation companies, global automation companies who are working with our types of sensors as part of the work they do around IoT installations and providing managed service around the infrastructure. We are also working with the certification companies who are obviously wanting to start to work with us. Again, they are seen as trusted advisors with the customer. So we're now, I suppose, what's the word, programmizing the rollout of sensors based on whether it's risk-based inspection or some other enterprise driver. So hopefully we've answered the question there.
Great, thanks, James. I will take the last question here, and then we can respond to some other questions by emails. The last question is quite detailed on the aspects of CUI, and it's quite revealing. The question is that we need to understand where the sensors are placed, but the production profiles can change over time. The temperatures can change over time. The insulation inspection happens and the re-insulation happens. So the water seepage may change over time. So how do we tackle these? And the risk may shift from one location to other location because of these changes over time, because we're talking about many, many years. How do we tackle this? I think, you know, this is a layout question. How do we decide the best layout? You know, Mehrdad, what do you think on, you know, this is pretty much a good question around, you know, how do we decide the layout? Basically, looking at, you know, production profile and risk can change over time.
But this is very good question, and I think this is where a key component of deployment is, which is we spend a lot of time with the client's engineers trying to understand the operating conditions around it, not just the current one, but if there is a data available about the historic, have been their temperature variations the last couple of, say, if there's data available historically the last couple of years, and if possible, what are the ideas about the future. But I'm aware of that. Yes, it's not possible to say that this change does not happen. It happens. But the beauty of corrosion radar system and other aspects of it, or uniqueness of it, is the modularity of the system. So if you have one section covered at one point in time, and you want to connect another point in time, the sensors can be connected to one another without the need of extra electronics, if they are within the range of that particular electronics. So modularity may be a good answer to this problem of if there's a shift in the interest area.
Thanks, Mehrdad. I think that brings us to the end of this session, and you know, it was a great season of CUI Coffee with the grand finale of Corrosion Radar team presenting the predictive case for CUI management. And to the audience, please do like our LinkedIn page to get updates. We will restart the CUI Coffee later part of this year after a break. We will announce on the LinkedIn and different channels on emails. Please do like our LinkedIn page. And if you have interest in deployment in your facilities, please do contact. The contact is on the webpage, corrosionradar.com, as well as you can always get back for webinars, related queries on webinars@corrosionradar.com, or general queries are info@corrosionradar.com. All of them are available on the website. And I hope everybody enjoyed and learned something new about CUI, what are the trends, what digitalization and predictive brings to the table. And I have to apologize that we can't get back to all the question and answers, but we will do that through emails. Yeah. I have to thank all my colleagues. It's a great session with all colleagues on the same platform, and it's a personal satisfaction for me to bring all of them.
And Praful, can I just say thank you as the host of CY Over Coffee. You've done an excellent job, and we're going to miss you over the summer, raising your coffee mug. And,
well, I'll be around answering all the emails.
The question, Praful, what you have in there, is it tea or kahwa or mate? You never answer that question.
Yeah, I mean, a lot of people ask me two questions. Why, what is there in this? And why I'm wearing the same t-shirt all the time, you know? So t-shirt is an easy answer. I like blue, corrosion color is blue. And this will be a mystery for the next
I look forward to September to know.
And I was going to say, I really appreciate that you're keeping the social distance in your office. So I can see there's never no one around you. So it's a good that we all respect the law. Just Praful wanted to say one sentence at the end, obviously, apart from thanking you and the team. If one thing I want people to remember about corrosion radar in terms of technology, I always use the analogy of a nervous system. That we are trying to bring this nervous system to the assets. Very much like your body, that you have the pain. The first thing you know is where the location of the pain. That capability is missing from the industry. And that is our vision. And we will bring a nervous system to the assets and industry.
So with that nervous system approach, everybody keep safe, keep your nervous system safe.
Yeah.
In these times, and see you again next time when we join back.
Thank you very much, Praful.
Bye.
Thank you.
Cheers.
Thank you. Bye-bye. Cheers.
Bye.